Hey guys, it's Mr. Paulo, and today I want to talk about the scientific method. So to start, we need to talk about what science actually is. And science is a process that uses observations and investigation to gain knowledge about events in nature. All right? Um, you probably think only scientists use science, but that's not true. You've probably used science before. Let's say you saw something on TV that looked really good to eat. So you got on the internet and looked up a recipe and you made it. And maybe you made it a few more times, and every time you varied the recipe slightly to see how that would affect the taste. That would be science. Or let's say you just turned 16 and you got a new pickup truck, but all of a sudden one day your pickup truck stops running. And you have to diagnose what's wrong with it. You check the oil, you check the battery, you try and figure out different things that might be causing it not to run. You look up on the internet the symptoms for your car, and you try and figure it out, and then maybe you fix it. That would also be science. Alright, so anytime you research something, you look stuff up, and then you try and apply that knowledge, that's going to be using science. Let's go on from there. Well, let's talk about observations. The first one is qualitative. And I would say think about quality when you think about qualitative. Alright? And these are observations that deal with the five senses, such as touch, smell, sight, hearing, and taste. Okay? So if I would say that my head feels warm, that would be a qualitative because I'm feeling the heat coming off. So that's quality. Or if I said the couch is soft that I'm sitting on. The softness of the couch is quality, so that's a qualitative observation. The second type of observation that we talk about is quantitative. And when you think about quantitative, I want you to think about quantities. Observations that deal with numbers. So if I said there's two cats in the room, that would be a quantitative observation because I said the number 2. Okay. Moving on. What is the scientific method? It is an organized set of investigation procedures. There are 6 steps to the scientific method. Alright? Here's the 6 steps. So we have our first one where we ask the question. Alright? And then after we ask our question, we do background research. Then we construct a hypothesis. After we construct our hypothesis, which it has to be in an if-then statement, we test it in an experiment. Alright? After we do that, we collect data, and then we review that data and analyze it. If the data supports our hypothesis, then our hypothesis is true, and we report our results. If, however, the data does not support our hypothesis, then we have to go back here, think about it, and then try it again. Come up with a new hypothesis and retest it until we get a result that is correct, that a hypothesis is true. And then we report it, and we tell all the scientific community what we did and how we did it. And that's how science advances. People publish stuff in journals, a bunch of people test it. If it tests true, then it becomes scientific law, and it's like, that's it. Let's do an example of this now. So let's talk about Hunter Joe. So Joe has a question. He's about ready to go hunting next year. He's all pumped up about it, and he wonders what is the best type of food plot that he can plant that would get the maximum amount of deer to his property. So he goes on the internet, he does step 2, and he goes on the internet and he starts to research it. And he comes up with a few articles supporting 2 different things. He finds one article supporting alfalfa, and then he finds another article supporting clover. And he's torn, he can't decide between the 2. And so he keeps looking, and he just finds a few more articles about alfalfa than clover. So he comes to the conclusion that alfalfa must be better because there's more articles. But he wants to test it to make sure. So the first thing he does is he constructs the hypothesis, all right, before he begins the experiment. And he says that if he uses alfalfa, then he will have more deer than if he used clover. All right. So his test is that he comes up with he has 3 different food plots. He plants alfalfa in one, he plants clover in the other, and then he leaves the other native grasses. All right, and that's going to be his control. All right, the first 2 grasses, the clover and the alfalfa, they'll be as independent variables. He gets cameras. game cameras and he puts it on all three food plots. And those would be constants. The location is the same for all three food plots, so that's a constant. The amount of water they get is equal, so that's a constant. The amount of light that the food plots receive is also a constant. All right. And so at the end of his time period, he says maybe 2 months, and he watches them. He collects the pictures from the game camera, and he counts up how many deer were at each food plot. And if he has more deer at the alfalfa, like he said, then his hypothesis was true, and he would be obligated to report it on the internet. Maybe put a Facebook post, hey, alfalfa's king of the deer. Or if he came out that the clover, however, or the native grass were better, then his hypothesis would have been false, and he would have had to go back and redo his hypothesis and then retest it. So that's an example of how the scientific method's used with the 6 steps. All right, hypothesis. Hypothesis is an attempt to answer the question in the problem. It's written as an if-then statement. So here's my hypothesis for that example. If Joe the hunter uses alfalfa food plots next year, then he will attract more deer than if he used any other type of food plot. All right? Variables. So we have 2 types. The first one is the independent variable. All right? And it's also known as the manipulated variable. It is the thing that is being changed or tested. All right? Types of food plots would be my independent variable in that scenario. We have our dependent variable, also known as the responding variable. It is what changes as a result of the independent variable. So in our experiment, that would be the number of deer caught on the camera, because the food plots are the independent variable. The number of deer that go to whichever food plot, that is going to be our dependent variable, because it's affected by the independent variable. Okay, I control the independent variable. The dependent variable is dependent upon the independent variable. All right, those are ways to remember it. Control, the item that is being tested with no changes applied. It is used for comparisons. All right, and in our experiment, that would be the food plot that wasn't changed, but was still compared with the other food plots. That would be just where the local grass was grown, or the native grass was grown. The constants, things that are being kept the same in the experiment. An example of that would have been the game cams, or the amount of water that the food plots were receiving, the location, the amount of light they were receiving.